We are DevOps. So this is going to be a non-technical talk, but feel free to grab me after if you want to go for a technical talk or go for any of the technical details. What I'm going to do is talk about our evolution towards DevOps over the last year. So specifically, what we've done, what we've learnt, and some of the pain we went through that hopefully you can learn from and not do the same mistakes that we did. You probably know who Trainline are, but you may not realise how big we are. So we do about £1.9 billion worth of training ticket sales a year in the UK. We have 6.5 million visitors a month, and about 70% of our business now is coming from our mobile platform. So can I ask, who here has got the Trainline app on their phones? Excellent. The rest of you, please download it right now. Don't listen to me, this will be on YouTube later. Trainline has been around for about 15 years, so long enough to accumulate a bit of legacy systems and technical debt. And that's really what I want to talk through. So if I can take you back to June last year, it was a dark and miserable time. We had a number of challenges, including a monolithic application, so all written in .NET, all Windows, and it was all integration by database. So we had this massive Oracle database behind the scenes, and one part of the system would write something there, and another part of the system would read it out. And of course, this was all undocumented just to make it a bit more interesting. So that was a major challenge. We managed to do one release every 6 weeks. And these were big rocket launches. So upfront planning, upfront testing, rolling out to our staging environment, everyone coming in at midnight, going through, taking the site down for about 5 to 7 hours, and then crossing our fingers. And to be fair to the guys, 99% of the time, it worked fine. But it was quite frustrating as a developer if you finished something and had to wait 6 weeks to get it live. Legacy tech, oh boy. So we had some Windows, which you could argue is legacy, but we had Windows 2003, which definitely is. We had some BizTalk, we had some MSMQ, we even had some horrible VB6 stuff lurking in the dark, evil regions of the codebase where no one dare venture. So yeah, we had a load of legacy tech, and we also had some legacy hardware. So we had some Oracle Exadata machines and Citrix NetScalers and other things which aren't particularly cloud friendly. We had one physical data center, which was a colo based in Rotherham, and we had a reasonable DR solution, which would have taken us a few days to stand up. We had centralized ops, so all the infrastructure knowledge, all the support was in a central functional team, rather than anything that developers could directly interact with. And we also had a number of challenges around our environments. So creating a new test environment was, again, a dedicated team, and it would take 2 weeks for that team to stand up a test environment. Some of you are looking like that's a good thing? That's not a good thing. If that's a good thing for you, then don't worry. Okay, so we had a number of challenges, lots of problems. So the business decided to set us a challenge, and the challenge they set us was this: go faster. Sounds simple, right? But actually, it was a fundamental change to our culture, to our processes, to our technology stack. It meant moving to the cloud, it meant moving to continuous delivery, updating all the technology stack, and moving also from Windows to Linux wherever possible as well. So a major undertaking. Turns out very. Where do you start with something like that? Well, we started with organization. So previously our teams were project focused, so we had a project which had to be justified by a business case, and therefore things like technical debt were really top of the list. So the first thing was to move from projects towards products, and to break down the organization from functional teams into small empowered teams. So we call ours clusters, but there are other comedy names available like tribes and other things. But we have clusters, and clusters are small cross-functional groups with some development, some testers. We've split out our central operations team and put a DevOps person in each of those teams as well. Split out the functional testing team and split those out as well. And we have now got a number of clusters. So the obvious question is how you decide how many teams you have and what they each look after. How many of you heard of Conway's Law? Excellent. Software reflects the organizational structure that produces it. It's so true. Imagine you're building a compiler and you've got 4 teams. You are going to have a 4-pass compiler. You just are, right? Now, what our chief architect came up with was called the reverse Conway maneuver. And what we did is we deliberately structured our teams around the architecture that we wanted to have. And sure enough, by surprise, each team was like, well, I'm responsible for this, therefore I want to build, test, deploy that bit independently. And naturally, we started ending up with API contracts and more isolation than natural break, and the monolith split down into microservices, or at least small services. So that helped deal with some of the organizational challenges. Then in terms of cloud readiness, so I think it's really important when you're undertaking any kind of cloud migration to be really clear about what you're trying to achieve. You can just lift and shift stuff as it is. You can lift and shift and remediate a bit, or you can build new stuff in the cloud and toggle over to that. So what we did is we created a checklist just to set the expectations of what the sort of bar was for the stuff moving into Amazon. And our bar included these things. So first always the Trainline security, making sure we've got TLS everywhere, loads of other things in there. Tech baseline, getting rid of Windows 2003, standardizing on 2012 where we had to have Windows, upgrading .NET versions, things like that. Getting rid of file shares, which obviously don't work so well in the cloud. We had a load of things referencing things by static IPs and assuming that they were all going to be there forever, so getting rid of that and replacing it with DNS. Getting rid of singletons, we did quite well with this, but we've still got a few lurking around. Dealing with any licenses which aren't cloud friendly. And finally, ops ready. And by that we mean the support guys know how to support it. We've got central logging via ELK. Just making sure that it's documented and understood what the monitoring requirements around that component are as it moves in. So that was our baseline. And I suspect we aimed a bit too high with this. We ended up creating quite a lot of remediation, some of which we could have done after we were in the cloud. So, cloud remediation. First step, planning. This is where it all went wrong. What we had was our data center and a contract agreement that we were going to be out of there in about 12 to 18 months. So we had essentially fixed time, fixed deadline, and fixed scope must be in the cloud. Simultaneously, we magically created all these empowered agile teams who had no experience of moving things to the cloud and were therefore completely unable to give us any kind of velocity or estimates. So the dev teams quite fairly were saying, I don't know how long it's going to take. And the execs were quite rightly going, well, this is a major project, lots of cost, lots of risk, when's it going to be done? So my strong recommendation is if you're going to do cloud migration, try not to do it alongside a compelling event. This was a cultural clash which caused a lot of tension throughout the project. The other thing is beginning early. So a lot of the things that you want to do to get into the cloud, you can do now, right? Almost regardless of which cloud provider you're going to use, because things like stateless architecture, horizontal scaling, blah, 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 all these things are good practice regardless of where you're hosting, but especially in the cloud. So you don't need to have all of your cloud stuff finished before you get on with it. And it's likely to be the longest part of the project as well. As I mentioned earlier, it's far better to build in the cloud rather than, say, go through your checklist in your current environment and then report it to the cloud. That way you're actually gaining experience whilst you're doing it in the cloud. I think some of our teams maybe took the checklist a bit literally, like it must have all of these things before we put it in, rather than doing some of the remediation in place. And finally, cloud fit. So a couple of scenarios here. One, we had an Oracle Exadata for our data warehouse. If you don't know, Exadata is a big hardware software Oracle solution. Nice bit of kit, completely incompatible with the cloud. It would have been a disaster to try and move our data warehouse into the cloud, so we moved that to TeleCity instead, and that was the right choice. We also had a legacy VB.NET something or other application, and we actually spent quite a lot of time and effort trying to move that into the cloud, and probably we shouldn't have bothered. So it's really worth being clear on what things are worth the effort and what things you can put somewhere else for the time being. Okay, that brings me on to strategy, architecture, and standards. These are all good things. I think actually this is an area where we did quite well in that we defined enough that we got started on the right foot and didn't make a mess, but not so much that it became confusing or it was difficult for anyone to understand and get into. What I would recommend is having at a minimum, these things. Firstly, an environment strategy. What environments are you going to have? Dev, test, staging, non-functional testing, UAT. Who owns them? How do the promotions work between them? All of these things are good to understand up front. The AWS architecture, what accounts are you going to have? What VPCs? How are the network connections going to go in? These are questions you're going to get time and time again across the organization, so writing them up front saves a lot of time. You cannot retrofit a security architecture. We deal with millions of credit cards. So, as you would expect, this is top of our mind, making sure we've got all the defense in depth that you would expect. You can't retrofit that. So being clear on how you're going to do that, and in our case for the PCI compliance as well, is really important up front. And finally, standards. So I would say the minimum you probably need is IAM, naming standards, tagging standards, how you're going to use S3, and security groups. If you've got one page on each of those, that's probably enough to get you a good way into the journey before you need anything else. Migration approach. So the way we did it was this. I'm not necessarily saying this is the right way to do it. This is what we did. So we started with the common infrastructure, which was all the VPNs, NATs, bastions, databases, rabbit queues, all these kind of things. And then we started migrating our services, and we migrated the services one at a time, and each one went through dev, staging, production, all the way live. And the way we picked the services was based on risk and latency. So the low risk ones to start, and the ones which are latency sensitive to begin with, gradually getting more and more complicated. Now eventually we reached a point where we had to tackle a big Oracle database, and that required a big bang. So this was actually quite a big bang, and we had to migrate not just a database, but about 10 core high-performance services around that, which are so chatty they had to move at the same time. And for that, we actually used our Amazon Enterprise Support. So they do an infrastructure event infrastructure event service, so they come and help. So we had Amazon on site overnight, had a big outage, kind of like the old releases, and did a big release. And obviously loads of planning for that, lots of running into staging first, rolling back, and going forward. And then finally we finished off with the other services that couldn't necessarily move until that was done, or which were just lagging behind because of remediation and stuff. Process and governance. I'm going to go over a lot of different topics very quickly here. There are obviously two schools of thought on this. You can do preventative process-based things where you try and stop bad code going out in the first place. But even if you do that, you still need a way to monitor the code and fail it back if it's got a problem. Or obviously you can go the other way and go all the way to continuous delivery where you let things out and you rely more on monitoring than upfront process. We went all the way to continuous delivery. And it was supported by these four things. Firstly, New Relic. Oh, it's expensive, but it's really good. It's really good. So we rolled that out everywhere. All our developers had access to it, so they could see immediately if they'd released something which had caused a problem. Blue-green. So all our deployments were blue-green deployments or canary deployments, and that meant that if we rolled out and we saw it was a problem, we could just flip it back by changing the load balancer. So within 10 seconds or so, customers were seeing the old version again. Automation. I'll talk more about automation in a moment, but automation of your governance is important. So we have defined all these naming standards, tagging standards, and so on. I don't want my developers to have to go to the wiki to find out what they should call their boxes. It should be automatic. So what we did is created APIs for deployment and toggling blue-green and things like that, whereby they just have to say deploy this service to that environment at that version, and it takes care of it for you. And that saved a huge amount of time. And finally, retrospective checks. So there are some checks which you need to do every time you deploy, and there are some checks which actually you don't have to do every time. So for example, performance testing. Right? Most of the time, most of your changes are not going to cause a major performance regression. So it's okay to push those through and then fail back with using blue-green if you find a problem. That's better than having a big NFT part of the process where you have to stop, do performance testing, and then you release the code. Same for security scanning. So we run our code security scanning overnight. For services which are low security, we can do that overnight quite happily. For ones which are high security, we have it as part of the build pipeline and release process. So adjusting that based on the service as well. So automation. I think the main lesson we learnt here was about using the right technology for the right problem. And there are lots of different problems in this space. So talking specifically about infrastructure as code, these are the three things that we used mainly. So first was CloudFormation. This was used for VPCs, for the security groups, the NACLs, all the core infrastructure. It was also used for standing up the common infrastructure services, so the hardware for the database server and the Rabbit servers and things like that. But that's where CloudFormation stopped and Puppet took over. And Puppet was then responsible for specializing the server to the function it was going to serve. And finally, we also had a lot of Lambda scripts. So Lambda we use for governance and for housekeeping. So we even have a Lambda script which does scheduling of our environments. So based on the tag, it will turn off the servers at a particular time. So when you go home at 6 o'clock, and boot them up for you so they're ready when you come in the morning. It saves a lot of money on our test environments. Deployment. I could probably do an hour just on deployment, but I won't. And instead I'll put this up. There are many types of deployments. I'll give you a moment to take that in. Yeah. So on the far left we have, my God, that is an ugly dog. Because pets are ugly, right? Well, our pets, obviously, our pets are lovely, but pets in the server room, that's a bad idea. So I'm talking here about singletons, things which have to be manually patched, things with static IPs. Okay, hands up who's running Windows production loads right now. How many of you have got singletons on Windows? Okay, how many of those have got static IPs? How many of those are doing blue-green deployment? Not many people are doing this, but this is Trainline's problem. So we can't get rid of all the legacy stuff straight away. It's going to take us time to clear that up. So in the meantime, we have to support these ugly pets, but we don't want to stop our developers from innovating and using the new stuff in Lambda and containers. So that was the problem. And we looked at lots of different automation tools in this space, and we came to the conclusion that actually none of them really fit our requirements. So we ended up building our own. And it's called Environment Manager. And what it does is manage environments. So it's a self-service web portal, and it's also a set of APIs. And what it does is it lets our developers do all the stuff that they previously needed to talk to our infrastructure team to do. So they can create their own environments, they can deploy to their environments, they can toggle between blue and green, they can view deployments, they can manage the configuration of the server, change the size of the auto-scaling group. All these things they can do self-service. It's all secure, it's all audited, but it's self-service. Now, there's probably not enough time to give you a demo of this. If you imagine it's an environment abstraction over the top of Amazon. So in the Amazon console, you modify individual instances or individual volumes. What this does is manage it at a high level of abstraction, so it manages it at an environment level. Set the schedule for my environment to be off at 6 o'clock. So what I'll do is I'll just show you a few screenshots of it. I don't know if this is really going to be visible at the back, but take my word for it. These boxes here represent different server roles which map to auto-scaling groups. The lines within them are the services that are being deployed to that auto-scaling group. And then the little indicator tells you whether it's a blue-green, overwrite, or canary deployment. So at a glance, you can see what the topology of your environment is and what you've got deployed where. You can click on one of those boxes and set various things. For example, the contact email to send alerts to if the machine goes wrong, or the size of the machine, or the AMI to use, or the security group to use, and so on. So you just set these things up, and then you call our deployment API, and it will use this configuration and create the infrastructure for you, using all our naming standards, using all our tagging standards, setting everything up in a correct security zone based on your settings here. And this is a view of the deployments page. So we've got some operational reports as well. And this is showing you the deployment. So what deployments have happened, to which environment, who did them, did it work? And if it didn't work, we can view the logs and see a detailed view of what exactly went wrong and then get fixing it. And as I said, there's a load of APIs behind this as well. So the front end is written in Angular, the back end is written in Node, and there are APIs under each of these sections that are Swagger doc. So for example, under deployments, you can see, can't see, but trust me, there's a deployment API where you pass the environment, the service, and the version, and it takes care of the rest for you. So how do we use this in our pipelines? Very simply, if you're doing a blue-green deployment, you would call getSlice API first, find out which is the inactive slice, which is the one you're targeting for your deployment. You would then check the schedule, see is that machine actually on at the moment, or is that server role set to be on at the moment? And if not, you can turn it on. Then you call deploy, and once you're happy the deployment succeeded, you call toggle slice, and it will toggle the version, and customers will start using that new version. Behind the scenes, there is loads of shiny technologies. So Angular, Node, Nginx, Dynamo, Lambda, and Console. And I'm very pleased to say that this is actually going to be open source. Split out our application to lots of microservices. We've got continuous delivery. We're doing 70 last week. We have distributed our operations, and we've made everything self-service. So everything's good, right? Well, not necessarily. So I think it's worth pulling out some of the problems that we had during this journey. Obviously, Mr. JZ there had many problems. We actually had more, I suspect. First being agile teams plus a deadline. Just don't do that. don't do that. An interesting one is empowered teams versus central tooling. So at one point, it looked like we might end up with 15 different deployment mechanisms, every team wanting to own everything. But I think that's an example of micro-optimization. The company as a whole does not need 15 deployment mechanisms. What you do need is one deployment mechanism which is sufficiently vague or sufficiently unopinionated that everybody can use it and do what they need to do. So that was an interesting debate for a while. As I said, I think we set our remediation baseline too high. It was a conscious decision. We wanted to stretch ourselves, but there was already plenty going on, and I think we probably could have done with a bit less in there. Hybrid environments. So we were in a situation where we were moving one service at a time, and that makes a lot of sense because it minimizes the dependencies between the teams, but it also means that you have to run your old environments and your new environments for longer. So that's 2 sets of tooling, 2 sets of standards, 2 sets of everything that you have to keep in your head. So I still think that moving one service at a time is the right thing to do at the start, but I think once you reach critical mass, it's probably worth looking at doing it in an environment at a time, so that you don't have to maintain both environments for so long. Another interesting side effect of all the automation we added is that it actually created quite a lot of uncertainty in our infrastructure team. So what am I going to be doing if everyone can do this themselves? So there was a management exercise there to make sure that everyone had a career path to grow and to explain how you're actually going to be doing more interesting work now that the simple automatable stuff is done. You can focus on higher level value and improvement rather than just firefighting all the requests you're getting. I couldn't do this slide without talking about code deploy. AWS code deploy. I think we were drawn to it because it was a native Amazon service and we wanted to stay as native as possible. But we didn't do enough testing of it and it wasn't suitable for our requirements. In particular, it doesn't do multi-tenancy properly. And we needed to do multi-tenancy with some of our Windows boxes. And there are also race conditions if you're scaling up whilst you're deploying. So overall, that was a poor choice, which cost us quite a lot of time. We've now got a new deployment tool, which is based on Console, which will all be part of the open source in July. And also load balancing. So our load balancers were in a real mess. We had one load balancer in our old test environment, which had 21,000 lines of configuration on it. And of course, this was all configuration which couldn't be tied to any of our services. So you didn't know if you could delete it or not. Now, we did not want to tackle this mess as part of this, because we had enough to do. So we talked to Citrix and said, hey Citrix, we're using NetScalers at the moment. Can we use your cloud version of NetScaler? No. No, we can't. Suffice it to say that some enterprises do not get the cloud. We ended up with a Nginx solution, which is all fed from dynamic configuration in DynamoDB and API driven for toggling and setting up things. It's a very nice solution now, but I wish we hadn't had to do it as part of all of this other stuff going on. Okay, so some takeaways. Don't do cloud migration to a deadline. Have a cloud checklist and just enough architecture. You can very easily, particularly in Amazon, get in a mess where everyone just creates things with different names and then you can't secure them and you can't allocate the costs and everything else. Be clear on remediation goals before and after cloud, so what you can do before and what you can do after. Centralize the core tooling, but make it flexible. So next for us, we are expanding out across Europe. So we're going to try and replicate this, make it more multi-geography. AWS optimization, so we're going to be doing a lot more, not just cost optimization, but using more native Amazon services. So SQS rather than Rabbit, making more use of Lambda in our code. Loving the Linux, looking at .NET Core, moving more and more towards Linux. And bigger data. So we're doing a lot of things, trying to use our customer data to make the experience better for people. Things like, did you know if you waited 10 minutes, the next train is not so busy? Those things would make life a lot easier. And we're well on the way with a lot of these big data initiatives. And that's it for me. Please download our app if you haven't already. And have we got time for questions?
Thanks very much, Chris. Any questions?
Yep.
Cool. Mark, you got the microphone somewhere? So I'll take this one. Sorry, where was that one?
Hi, I thought that was totally awesome and a real success story. I'm wondering how big your development team was for doing this project.
So again, how big the team
How
was?
big the team was?
So the infrastructure team was around about 40 people. We have around 200 or so in our technology team as a whole. So the majority of the work was remediation on the app, so that was mainly the development guys.
Yeah, I'm interested in the whole Oracle Exadata thing.
Mm-hmm.
At what point in your considerations is moving that to the cloud? Is it something that's just too big to move, or is it something that you're going to use an Oracle cloud-based service, or have you considered RDS?
Yeah, great question. So the Oracle Data Warehouse only works because of the power of Exadata. People are throwing awful queries at it, and it's just handling it because it's got the power. We wouldn't be able to run it in the cloud, even on their biggest instance. What we're doing instead is building a modern EMR-based and Redshift-based, so some static, some things, but we're building that all new, all cloud-native, and then we'll turn off the Exadata.
Any more questions for Chris? Yes, over here.
How did you choose the AWS, and are you concerned that you're using native products?
We chose AWS because it's the clear market leader. It's just innovating far faster than the competition. And no, I'm not overly worried about tie-in with Amazon because it's not the same as the old Microsoft tie-in because it's API driven. And a lot of the open versions use a very similar API in any case. So I'm not overly worried about that.
One last quick question, Oracle again. Store procedures, how much do you love them?
We do not. We have plenty though, which is
that the big barrier for you?
and triggers and no end of our ETL process was even within PLSQL. So it's just unpicking that would be a monster, and that's why we're just building a new one, and then we'll run the workloads, compare the results, and swap over once we're happy.
Hi, I'm completely new to DevOps and I don't have a technical background, but I'm curious about it because I'm a business analyst.
Mm-hmm.
I'm wondering within this whole framework, where does rapid prototyping and A/B testing fit with DevOps? Because I understand it's all about lean and being agile, but how do you work with those other teams, or did you?
So every change we put out goes through MVT. So we have a percentage of customers, every change for the front end stuff. We have a percentage of customers going through this version and a percentage going through that, and we monitor the conversion, and we know which is the better solution based on that. So we do a combination of MVT with blue-green toggling. So we do it based on data. Lots of questions.
Thank you. I know you already said that you have made a decision regarding how to move the Exadata stuff. Considering the fact that right now you can get Exadata instances on Oracle Cloud, did you ever at any point consider marrying two cloud solutions together?
And the reason for that is if you do cloud brokerage, which is what you're talking about, you end up working with the least common denominator of all of them, and you're not able to take advantage of the the innovation that Amazon are bringing. And Oracle Cloud is not something that interests us. So we're going to get rid of XA.
You talked about deployments. How do you write software now? Do you still do on-prem development, or do you use off-prem like a VSTS solution or external GitHubs and things like that? How do you do that?
We have our own hosted GitHub. We do development all in-house. So one of the first steps, which was actually before last year, was insourcing. Previously, all our infrastructure was managed by Capgemini, and we moved everything in-house so that we had control, which then was the foundation of being able to do this. So as much as possible, we in-house, but that doesn't mean we don't use SaaS services where they make sense. And we do use a lot of those for translation and various other things.
Thanks for the really interesting presentation. How are the business measuring how well you're doing?
How's the business? Conversion. So we grew at about 24% last year. And the fact that we have achieved getting into the cloud without getting kicked out of our data center.
Cool. Any more questions for Chris? Yeah, one more over there. Okay.
So I'm a big believer in the idea that every business is a software business, whether you sell it or not. So, but I'm kind of coming to this with a regular conference more as an IoT guy. So how would you define DevOps kind of to the uninitiated?
Okay, so firstly, I agree with you. We are very much an IT company that sells train tickets. No question about that. And there's no gap between technology and the business here. How would I define DevOps? I would say DevOps is a culture of close interaction between developers and operations people. I think it's a set of best practices and processes that support that, including, developers on call and visibility of production metrics everywhere. I think it's also a role in that there's certainly a specialty around automating that core in a loop of deployment and the tools that you use for that. So I think it's all those things. It's a culture supported by processes and specialists who have the technology.
Awesome. Okay, just time for one more.
Hi. I just wondered whether you faced any challenges delivering the product roadmap at the same time as doing the migration.
Great question. We weren't allowed to. No, this is kind of like building a new bus while the old bus was rolling along. And then each group had to have its own bespoke seat, and you weren't at any point allowed to stop. We stopped the business deploying new things for about 3 days in total. So whilst we were doing this, we also did the big rebranding, which you may have seen, hopefully. We also released Apple Pay, guestless checkout, loads of functional things. So yeah, we weren't allowed to stop that.
Excellent. Okay, great questions. Thanks very much to Chris Turvil. Thank you.